Welcome to the fourth session of the fifth International Symposium on Occupant Behaviour, organised by the Sustainable Energy Research Group at the University of Southampton. Please note that this session is being recorded. As Backer said, I'm Professor Patrick James. I'm a Professor of Energy and Buildings, and I'll be chairing this session on modelling and simulation. As Stephanie has already said, but I'll repeat it, attendees should ask questions through the question and answer session, where they can upvote using the thumbs up to promote a question. Attendees should only use the chat and raise hand if there are technical issues from their side, and then some magic will happen in the background by the moderators. The format of the session is 3 8-minute talks, and then 4 3-minute talks, and then we have a 25-minute question and answer session. So please promote your questions during this session, so we can have a really engaging discussion at the end. Presenters, be ready to go. Timing is strict. If you are doing the longer talk, you will get a 2-minute warning from me, from my glass. If you are the shorter talk, you will get to tell me that time is over and you need to stop, and we will cut you off. Yeah, timing will be strict. Okay, so I think we can go to our first talk. So this is Julia Day. What does a zero energy and zero carbon tenant look like?
Good morning from Pullman, Washington. It's quite early here, but I'm ready with all of my espresso here. So thanks for having me, and thanks for the introduction. So as I was putting this presentation together last week, I realized that my original title was actually a horrible title for what a net zero energy and net carbon tenant look like. But what I was really more interested in is how they behave. So I've reframed that a bit. And I also should preface this with, I am not a modeler, so I'm not quite sure how I'm in this particular panel, but I hope that what I've learned through this study and through what we're doing with McKinstry, that some of those lessons will actually be valuable for modeling. So we can get there and discuss that later on as well. So let's see, there we go. So first of all, I just wanted to start with the project that I've been working on this past 9 months with our research team at the Integrated Design and Construction Lab, is we're working directly with McKinstry and Avista, they are co-owners of this new development. Avista is a local utility, and McKinstry is a large mechanical contractor. So they're using this building to be a catalyst for zero energy buildings and low carbon kind of innovative construction methods in our area in Spokane, Washington, which is about an hour and a half from where I am now. So this is a rendering. The building is actually not complete yet. And it's the first phase of the full development project that will eventually connect the Catalyst building over here on the right across this new bridge that connects to the University District in Spokane. So there you can see WSU Spokane, my university. There's also Eastern Washington, Gonzaga, and so on. So it's a cluster of quite a lot of buildings there. And there's a huge health focus in a medical school. So a lot of what they're doing for this building ties in not only to energy reduction, but also health. And so we're trying to keep those themes consistent across the two. So many state-of-the-art energy saving kinds of design strategies went into this building. It also uses CLT, which is cross-laminated timber, carbon sequestering kind of material, which I know is not a new thing in Europe, but it is fairly new over here in the States. And here in Washington, we're sort of in a hot spot of that. Quite a lot of production going on with Katera and a few other companies. So the reason our lab has stepped into this was they've done quite a lot of energy modeling for this building. They have photovoltaics located on site, and they have very aggressive energy goals, obviously, with the net zero goals. And they've realized that occupants play a critical role in achieving that net zero goal overall. So we were tasked with putting together a tenant engagement program so that we could help teach occupants how to actually maintain that zero energy budget, and if not, do it even better. So our scope last semester tied together these 5 primary topics, and this doesn't look like maybe a cohesive literature review paper at the moment, because these are specific topics that we were asked to approach from the owners. And so it's this might be 2 or 3 papers that come out of this in our academic world, but in industry, they wanted to know specifically about what are some of the similarities between the sustainability programs. So things like the WELL Building Standard, LEED, BREEAM, and so on. So we were looking at, what are user-focused kinds of things that come out of those programs? What are different types of current occupant engagement strategies that have been used in other kind of green or high-performance building facilities? And then we looked at how to engage occupants through those, specific technologies and apps to engage. I was really excited to see Clayton's presentation yesterday, because I think that can actually work really well with what we're doing. We also looked at case studies, and then we were involved in their lease process, where we put in some green lease language to actually help the tenants understand maybe what their responsibility was in the building. So first up, similar to the WELL Building Standard, we actually, like I said, looked at several different rating standards and started to look at primary topics that came up over and over again, and topics that were really very related to not only the building, but the users of the building. So things like health and well-being, community, access to light, thermal comfort, all of these were very important components. So what this did, and our case studies that we did later, is it started to inform, how will our tenant engagement program, what will it focus on? Are we going to do different kind of themes every month, every quarter? So it starts to kind of trigger some of the things we're doing with our tenant engagement program. Many of the themes that, like I said, came up in these different systems related to education and training of both operators and users on multiple levels. So we knew that was definitely something important to include. Feedback, so whether that's through a kiosk or something much more robust than that, those were definitely things that we saw over and over. Real-time displays, this feedback mechanism we did see over and over in the literature, not only in the review of systems, but when we started looking at the behavioral theories and some of the key frameworks that are out there, started to understand these 3 different, so you can't see where I'm pointing, so I'll use my actual cursor here if I can move it over. I can't, but I'll just walk you through it. So these 3 things in the top graphic, from a lot of the behavioral research that we had done, were very clearly needed for our tenant engagement program. So social interaction, and actually having some kind of competition in that, and feedback mechanisms really led into this gamification concept. So we're looking at different ways to engage occupants through social interaction, but also through technology to get them excited about saving energy, but also focus on things like health and well-being, and understanding how energy and health can complement one another if we approach that carefully. Because I think a lot of you already know there's a lot of things that happen, like having a really tight envelope and having poor ventilation in some cases. So a lot of times our energy saving efforts might backfire in terms of occupant health. So we're just trying to find a balance between the 2, maintain the net zero, but also keep the people happy and healthy. So when we were looking through applications, we reviewed over 40 different apps and different types of technologies to engage occupants. And this list of 10 are different concepts that we recommended to McKinstry after reviewing those. So something that offers feedback, peak time, energy use and management, some kind of user-centered experience, an onboarding process where they're actually learning why they're trying to save energy in the building, different types of user profiles so that we can actually enforce and engage them through some of that gamification. Translated energy use metrics, we found some that would equate the kilowatt hours to like how many trees were planted or something like that. And having that kind of visual connection there helped a lot of the occupants understand. Occupant training.
Go the rest, quickly flick through the rest of the slides.
Yes, I can do that. Do I have 2 minutes left or 0 minutes?
That was time.
Okay, sorry, I didn't hear your clink.
So we can see them quickly.
All right, perfect. So we did several case studies. These all relate. Then we also, like I said, offered some language for the lease. So what this all means is we put together matrices of all the different types of tenants in this building and different types of engagement strategies, and starting to look at a best practice kind of matrix for how we should engage different types of tenants. And then this next year we will be implementing this, and then measuring outcomes and using this as a research study to find the best types of tenant engagement strategies to find that balance between health and energy. So thank you.
Okay, thank you. I have a question from the floor from Clarice Bliel de Souza. She asked Julia, what do you want the engagement for? Is it to induce behaviour, to control behaviour, to persuade behaviour, to gather feedback about how the building performs? How are you going to categorise your findings, on what criteria are you going to use?
That's a good question. So it's a little bit of all of that. So we're engaging the occupants on the first level to educate them how being in their new net zero building is very, very different than their traditional buildings. On another level, part of the whole reason for this development is to connect it to the community. So we're trying to teach them energy efficient strategies in the building that they can then take out into the community. So there will be education that relates not only to the commercial building, obviously, but things they can do in a residential context. And then in terms of the human building interface, we're also teaching them through this engagement how they can engage with the building in ways that will help maintain their comfort, but also they'll understand any kind of energy consequences or when they should not be interacting with the building. So multiple levels there of why we're engaging them.
Okay, thank you very much.
Right. Thank you.
Okay, so now we move to our next speaker, Isabel Mino-Rodriguez.
Thank you. Hi.
And their talk is Effectiveness of Feedforward Information System on Occupants' Behaviour. Okay, the floor is yours.
Thank you very much. Good afternoon to everyone. Thank you for the presentation. As you already mentioned, I will be talking today about the effectiveness of feedforward information systems on occupants' behavior. The aim of this study is to understand which are the key design components that should be considered or included in the design of feedforward interfaces. And which will be the potential effect that this interface will have on modifying occupants' behavior. Let us start first by defining what is feedforward. Feedforward is a strategic flow of information. This means that whenever any occupant have any intention to adjust or in their environment, feedforward, it means that we will provide with some forecast of the output in terms of which will be the output of any actual behavior that they will take in the current or in their environment and in the energy consumption. This forecasting output will be used as an input for will be provided as an input to the participants, and it's intended to active or to redirection the coping responses of occupants as they react to the perceived conditions of the environment. But why it is important to focus on the design of effective feedforward interface? The effective delivery of information to occupants, among other factors, relies on the quality of the communication and the level of persuasion use. Therefore, there is the importance of the design of a feedforward interface and the potential effect of the well-structured piece of information whenever we try to modify or to reactivate or redirection occupants' behavior. So based on the literature, there are some key components that could be categorized whenever we designed it. There are 4 key components that we can consider when designing any piece of information that is going to be provided to users or occupants to receive some information about the building. This could be, we put in like what is being informed to the occupants in terms of the granularity of information. It's either actual, historical, or comparison. It's in the content that we are providing and also the target audience. In terms of how the information is being presented, which is the format that we are using to provide information to participants, and the means that, the technological means that we are using in case that we are using digital interfaces, for instance. The access to information will be accessed individually or collectively, and the context where the participants will receive the information. And also very important is when the information is being revealed to each of these participants, like let's say which is the point in time, the latency, the frequency where they will be receiving information, or the duration period where they will be receiving this information. So for this study, we are exploring the feedback collected for 76 participants in a naturalistic office environment after interacting with visual interfaces that provided some information about the comfort level and the energy use. Informations received, the participants received like 2 options of feedback, let's say 2 different graphic interfaces. Option number 1, it provides them information in terms of the time until any change of the comfort use and the energy use. And the second option provided them, it was a combination of 2 graphics that provide them with comfort level information also in terms of time and the energy use in terms of time. Participants have these 4 options or actions to take to restore thermal comfort in terms of removing a piece of clothing, operating windows, switching on the ceiling fans, or switching on the air conditioning. So after receiving these information, participants were asked if they were wanted either to have the same action or to take the same action that they were intended to take before receiving this information, or if they wanted to change their their choice on the action. And in terms of when this information was revealed to them, that was revealed only once because it was an experiment. So let's look now into which was the assessment received from participants in terms of these 2 interfaces, or the graphic interfaces that they saw. So participants were asked to rate some statements in a 5-point rating scale that goes from strongly agree to strongly disagree to strongly agree. And they were asked to what extent they found this visual interface useful, trustworthy, informative, if there's some information missing, if the graphic was easy to understand, and if the graphic was clearly arranged. We can see here the responses for the option number 1 and the option number 2. As the aim is to enhance the design of the feedforward interface, we will focus on the, let's say, the negative responses of people, what people strongly disagree. We found out that people didn't find information trustworthy for the first option, that there was also like quite a lot of information missing, and that the graphic was clearly arranged. In terms of option number 2, they found all the same, that the information was not trustworthy and that there was some information missing. However, in terms of this combination of graphics, they also found that the graphic was not, at least for 25% of the participants, they didn't find it easy to understand or clearly arranged. When analyzing the open questions, participants were asked to provide comments in terms of which are the positive aspect of the graphics, any negative aspects, and any missing information. We can clearly see that people found by this size of the font that people find it like knowledgeable, clear, and easy to understand. In terms of positive, something to highlight is that option number 2 was mentioned to be more detailed. In terms of negative aspects, we can see that people, at least for option number 1, that they found misleading the use of colors in the option number 2. And in terms of missing information, aside from lack of units, they found that, that there was like lack of level of comfort. And finally, participants were also asked if the graphics affect somehow their decision, and they were also asked to respond by a yes or no to these statements. It's like if they will prefer the time, the temperature, and energy to be displayed in specific units, or if they would prefer comfort instead, if they would prefer the change to be displayed, the change in comfort instead of temperature, or change the display. Once more, if we focus on the participants that were not affected in the decisions in terms to enhance the design of the interface, we can see that in terms of energy, there's like split the responses between both of them. However, if we focus on the participants that changed their decision, time in a specific unit is something that could be considered for the design of the interface, and that people prefer temperature information rather than comfort. So to conclude the presentation, if we focus on what do people like actually would like to see on Feedforward interface, is not only the actual information in terms of comfort or energy, but also the long-term comfort in terms of content. They will also like to see alternative options, probably not fix them to specific options. They found quite difficult to understand some concepts related to comfort or energy consumption. They also found that they would prefer to have some reference on sources. Probably this is related to how much they trust information that was provided to them. And something very important, that they probably prefer to see like values on temperature rather than on comfort information. In terms of specific units, the responses were quite split. However, we could see that probably for known concepts such as time, participants will prefer to have a specific unit, but not for some concepts that are not that familiar for them, such as energy. And something else that we should be very careful whenever using shapes or colors when in the design of interface, because this could be like give an unclear message or mislead the interpretation of the message. That's it. Thank you. As I mentioned, these are an ongoing project, so any comments, feedback, or questions are very welcome. Thanks.
Thank you. Very interesting. I have a question from Michael Kane, who says, what were the demographics of your study population? I'm surprised that a general non-technical audience would care about units.
Okay, this probably the study was undertaken, the population was university students, so probably it's not that generalized. However, as I mentioned, this is an ongoing project, and the intention of these initial results is to be the input for developing this framework, or which will be the key inputs for the design of a Feedforward interface.
Okay, so were these engineering students?
What's a mix of, but yeah, mainly engineering students, or even some architects around, so it's probably like some by the population.
Okay, thank you very much.
Thank you.
Okay, thank you for your talk. We now move on to Anooshmita Das. Who's giving a talk, prediction of indoor clothing insulation levels. No, sorry, Adrian Chong, my apologies. Adrian Chong is the next speaker, I'm sorry. Quantifying the impact of occupant presence on building energy simulation with real and synthetic data. Thank you. The floor is yours.
Hi, can you hear me?
Yes.
Okay, awesome. Hi everyone, my name is Adrian Chong and I'm from the National University of Singapore, and today I'm going to talk about some ongoing research, which is to understand the impact of occupant presence on the building energy simulation. So this is part of ongoing research to understand how much information should be gathered so that we reach a desired level of confidence in the building energy model. So we did an initial analysis, input and output analysis, and what we found out is that the modeling of people is often modeled as uncertain, as well as their behavior, the impact on internal loads. And we start to think, with increasing data availability, as well as the advancement in occupant sensing and data acquisition, this could potentially become a measured input or output. And therefore, the question that we want to answer in this research is, what is the impact of occupant count information in reducing this gap, given an adequate calibration procedure? And so the method that we propose is to use a Bayesian approach so that we can more robustly quantify the impact in bridging this performance gap. And interestingly, as you all probably noticed as well on the right, is that using occupant presence directly to model in the model might result in wrong modeling of the base and peak loads. Therefore, in this approach, what we do is that we model the base and peak load as random variables. So we look at two different types of case study. One is synthetic data, where we make use of the reference building as well as the occupancy simulator. And we look at different spatial resolution from no occupant data all the way to occupant data aggregated by space. And then we proceed on to look at real data as well. So this is an actual building in NUS. And we look at having no occupant data, Wi-Fi data for the entire building, and where Wi-Fi data is segregated by floor. And of course, Wi-Fi data provides an implicit measure of occupancy and requires no modification to existing systems. And therefore, it's been shown to be suitable for creating profiles for hour-to-hour variations. And due to time constraint, I'll probably skip this. And what we notice is that the root mean square error with occupant information is lower than without any occupant information, but we do not see any significant impact going with finer resolution of occupant information. And this is the same for the field data, as in using measured data as well. And to wrap up, next step is to evaluate the subsequent impact on the specific purpose, even with improved accuracy, and to test it on more case study buildings. Thank you.
We'll take questions at the end of the session, okay? So now we move to Anooshmita Das and their talk, Prediction of Indoor Clothing Insulation Levels, a comparison of different machine learning approaches. Okay?
Yeah. Good afternoon, everyone. My name is Anooshmita Das, and I'm a PhD researcher at the University of Southern Denmark, and my supervisor is Mikkel Baun-Kegor. And the title is, as already stated, Prediction of Indoor Clothing Insulation Levels, a comparison of different ML approaches. So the objective here is prediction of indoor clothing insulation level. And the motivation behind that is that clothing insulation is a critical parameter in the prediction of occupant thermal comfort. And accurate prediction of clothing insulation levels is imperative for reducing the building energy consumption. However, lack of this information may result in inaccurate modeling of indoor comfort or miscalculation in the comfort condition required, which may result in poorly sized HVAC conditions. So we have these research questions which we want to address through this project. However, due to time constraint, I would just highlight one of the important one, which is what are the important parameters that has an impact on the clothing insulation of occupants, which is age and gender, seasonality, the lighting conditions, and other indoor environmental parameters. So in this research, we have used an Xbox Kinect to extract the data from the participants. And with the advancement of depth sensor technology such as Microsoft Kinect, it becomes possible to capture both color and depth images simultaneously. So in this slide, you can see that we have captured the data and that has been translated into an extended skeletal model. So the privacy concerns are reduced a bit because we don't reveal any confidential information here. And the depth data also provides accurate data about the shape and the geometrical structure. And this is our test setup, which is a zero emission building located at Troynham, NTNU. And this figure or this table represents the classification for the different clothing patterns. Here you can see 4 different colors, which is green, blue, yellow, and red. However, we have collected data for only the green region, and we couldn't collect more data because of privacy concern on the blue, yellow, and red. And the study period for this one lasted for around 3 months, which was 12th September to 10th of December. And we had 3 participants here, 2 males and 1 female. So the approach is that we had the data set collected, then pre-processing data cleaning happened, and then we further splitted the data into training, testing, and validation in the ratio of 70:20:10. And we applied 4 ML classifiers, which is KNN, CAT boost, gradient boost, and XGBoost for the classification task. In this initial result, we would show only the results from the investigation done on the natural and dark light settings. And for this, we have also corrected ground truth labels to validate the data annotations, which was performed for the classification task. However, it was manually very expensive. So these are few of the results on the 4 classifiers for the full data set, and we were able to achieve an accuracy of 86.78 for the KNN, which was the best performing out of the 4. And this is on the different light setting, which is dark and natural. And we can see that the accuracy improved drastically on the KNN for the accuracy, which is around 91.68%. So since this is an ongoing project, I would like to end here, and if any suggestion or comments are there, it's appreciated. Thank you.
Thank you, and thank you for keeping to time. Okay, we'll take questions at the end of part of the discussion. So can we now move to Alistair Mann and his talk, Analysis of Occupants' Presence in Homes?
Can you see it?
I can see me.
Okay, can you see the presentation now?
Yeah, that's good.
Okay, cool. Hi everyone, so I'm Alistair, and today I want to talk through a few findings I came across during my 3rd year project at the University of Southampton. So the project's in collaboration with the Care Team app, which is a collaborative effort between the university and the city council to try and alleviate some of the burdens borne by unpaid social care workers. And predicting occupancy or activity is actually quite useful for them because they can better manage their schedule and manage the burden between them and other people within the care network. So the Care Team set up a few motion sensors around a few trial homes, typically in the lounge and hallway, and these sensors would become active whenever there was motion nearby. So I took the amount of time each sensor was active for in a given hour of the day, divided by 60, called the activity ratio, and this was my main predictor for machine learning models. And I wanted to see how much lag of activity is useful for predicting activity 3 hours in advance. And what I got was this graph. So each red dot on this graph represents a linear regression model trained with a certain amount of activity lag, which is on the x-axis, and its corresponding R-squared score, which is on the y-axis. And for each amount of lag, I trained 100 models with different random states, and the blue dots represent the average performance of those 100 models. And what I observed with this house in particular was that there was a decreasing performance. There was decreasing performance with increasing amounts of lag generally, but there were sudden spikes in performance after 24 hours, 48 hours, and a week, some repetitiveness in the person's schedule. And extending this to 2 weeks or 3 weeks of lag, we did not observe the same sudden spike in performance, but the performance continued to deteriorate with more lag. So this wasn't observed with every house. With some occupants, there was a plateau after just 24 hours, suggesting daily repetitiveness. And with some houses, there was a slight decrease after just 1 hour's data. So it's important to know that this was collected in the social care context where the occupants might be less mobile or more repetitive than the occupants you are used to. But generally, there was a decrease in performance with increasing amounts of lag after around 2 or 3 days of data. And the main point I wanted to bring across was that the models are actually overfitting. So adding more data isn't always beneficial. It's only beneficial up to a certain point. But it's important to find out like what this point is, because in my case, I found that very, very specific amounts of lag suddenly improved performance of the models. But the big caveat is that the data was collected in a social care context. So as I mentioned, people could be more repetitive with care workers coming in at certain times of the day, or they just might not be moving at all due to their health condition. And then for the analysis, I mostly just use an R-squared score. So there's the corresponding limitations of that. Thank you guys for listening.
Okay, thank you. Very good timing. Okay, so we move to our final talk by Tariq Abumara, the impact of occupants' distribution of energy and comfort in a case study office building.
Hi, everyone. This is Tariq, and I'm going to talk today about the impact of occupant distribution on energy and comfort in a case study office building. So a designer usually assume a homogeneous distribution of occupants in buildings. However, in reality, buildings have different tenants, and occupants are heterogeneously distributed in the building. So the objective of this study was to evaluate the impact of intertenant diversity on energy and comfort performance. So in order to conduct this study, we had to create a base model for the case study building, which is a real building, and generate a number of random occupant distribution scenarios, and to identify performance metrics. And for this study, we used a model for a typical office building located in Toronto. The model had 15 thermal zones. And we used about 93 occupant distribution scenarios. They were randomly generated to represent different distribution scenarios in buildings. And for performance metrics, we used energy use intensity for energy and the unmet hours as an indicator of discomfort. And the study also included developing a new metric for comfort called occupant discomfort hours, which indicates the share of each occupant of discomfort hours. Observing the results, we can see that there is a modest impact on energy use intensity, given that we hard-sized all the HVAC equipment in this study. But when we look at the unmet hours, we can see that there was a wide range of discomfort, going from 150 hours in the standard occupant distribution to 3,000 when we have 3,000 hours when we have overpopulated zones. But unmet hours are a good metric to show the overall comfort performance, but it doesn't tell you where is the problem, which zones are suffering, how many people are suffering from discomfort. So we developed the new metric, which is called occupant discomfort hours. And we reported that in every zone, and we can see that the range of occupant distribution, discomfort hours was different per orientation and per occupant distribution. Lastly, we tried to find the correlation between the unmet hours and the total building occupant discomfort hours. And we found that they are linearly correlated. However, the newly developed metric was higher in value. In conclusion, we recommend that, so the occupant distribution had an impact on energy and a substantial impact on comfort. And we recommend the consideration of spatial variation of occupancy during design, and to use different or alternative metrics when designing buildings. Thank you.
Okay, thank you. Thank you for keeping for time. Okay, so that concludes the presentations.